So, with this mistake clearly in mind, this is a reason why we want to make sure we take our time and factor carefully. And it's another justification for why we check our answers. So, knowing what the mistake is, I'm going to factor this problem again. We will check our answers, and we will see that after we've checked and found our mistake, we are correct. So, recognizing that the mistake happened with the sign error when I uncombined my 5x, I'm going to come down here, using the same principle, and write this as 3x squared plus 6x minus 1x minus 2 equals 0. So when I break this and factor it by grouping, factor out a 3x, have an x plus 2, subtract the 1, and get an x plus 2. Setting this equal to 0 each time. Finish factoring, 3x minus 1, x plus 2 equals 0. 3x minus 1 will equal 0 when x equals 1/3. What I did there is in my head I set it equal to 0, much like we did down here. I moved the 1 over and I divided by the 3. You may skip to this step. You do not need to show me the linear algebra solving. Get rid of that mark. So, equivalently, this would be x equals -2. And these would be our answers. And when we check them, again, we will check both in the original equation, because that's the only way to know if we made an error. 3 times 1/3 squared plus 5 times 1/3 minus 2 should equal 0. Now, that is actually what I wound up doing on this line. The -1/3 that was present on my x squared itself away, and since I forgot to write the sign here, I thought that my equation checked out just fine. So, I've already done that math, it's on the page. I'm going to just say I know that that's true. But I would like to check the 2 value. So 3 times -2 squared plus 5 times -2 minus 2. Does that equal 0? This will give me a 3 times a positive 4. 5 times -2 gives me a minus 10. I'm going to subtract 2. Does that equal 0? I get a 12 minus 12. Yep, that equals 0. Since both of my factors equal 0, I know I did this fine. So, the steps for solving an equation like this, first, are to make sure if we're already factored, you can ignore step 1. But step 1 is to get your equation into standard form. And remember, that's our ax squared plus bx plus c equals 0. The next step, factor the expression. That is not going to go away. If you're not good at it yet, you will be. You're going to do a lot of it. Step 3 is to set each factor equal to 0. Once you've done that, you can solve, that's an R, solve for the variable from each factor. And then 5 is check all values in original equation. Someone recently asked me if they could check it in the factored form, and clearly, based on my mistake, you know that we cannot. So I would just like to quickly go through a few extra examples here. Something like this may seem intimidating, but the first step, get it into standard form. So when I do that, the first thing I need to do is distribute to get rid of my parentheses. So I'm going to have a 2x squared plus 10, and then I'm going to have another plus 10 on the side, should equal a negative 2x squared minus 20x minus 5. These 10s will combine, so I will have 2x squared plus 20 equals my negative 2x squared minus 20x minus 5. I need to get this equal to 0. So I need to move everything over to one side of the equation. So I'm going to add each piece over here on the right, each term. I'm going to add each of those over to the left. So 2x plus 2x, sorry, those were x squareds, so I get a 4x squared. I'm going to add 20x onto this, and I'm going to add 5 to 20 and get 25, should equal 0. I recognize this as one of the special trinomials that we saw in section 5.7. This is a perfect square, this is a perfect square. And if I take the 2x and the 5 that were squared here, multiply them together, I get 10x, multiply it by 2, I get this 20x. This is one of the perfect square trinomials. I will break it down, but I am recognizing ahead of time that I know how this should factor. But what I will do is I will break this 20x in half. 4x squared plus 10x plus 10x plus 25 equals 0. Factor this by grouping. 2x times 2x plus 5 plus 5 times 2x plus 5 still equals 0. So here I'm going to get a 2x plus 5 times a 2x plus 5 equals 0. This is factored. And looking at this, you may think you need to solve each of these factors, but if you notice, they are the same factor. This factor is 2x plus 5 squared. So to solve this, I need to set the 2x plus 5 equal to 0. I will subtract 5 from both sides. Let me move my check. Oh, that doesn't work. Okay. So I wind up with 2x equals negative 5, and then I'll divide by 2, and I wind up with ultimately x equals negative, how was it read that? Let me try this again, see if I can not drag things with me. 2x equals negative 5, divide by 2, x equals negative 5 over 2. Now we've seen But even when I solve these, I don't always get the right answer, so we need to check this. It would be kind of difficult to do this by hand, so we're going to check it in the calculator, and I'll show you how to do that in a moment. In order to check it, what I need to do is I need to make certain that 2 times my negative 5 halves squared plus 5 plus 10 equals my negative 2 times my negative 5 over 2 squared plus 10 times 5 over 2, close that, minus 5. I need to make sure these two are equal. And I have a feeling that you don't want to deal with those fractions. So what I will show you now is a way that you can do that in your calculator. So I've pulled up the calculator, and now I want to enter each side of this equation into the calculator and make sure that I wind up with things matching. I need to at least see this. And of course my calculator went away. Come back. I need to at least see that you plugged your x value in. So all I will do is I will enter this exactly as I see it into my calculator. 2, open, open, negative 5 over 2, close that one and square it. There's my x squared, plus 5, and I'll close that parenthesis, plus 10. If I hit enter, I get this value. Don't clear it. Keep that value. Now I'm going to check the other side. Negative 2, and then here's my negative 5 over 2, and I'm going to square that again, plus 10 times that negative 5 over 2. I made a mistake in my check again. I need to be very careful about that. Close that parenthesis and subtract 5. And I should get out the same thing. And I do. So this is what the check would look like in your calculator. When you do this, do not forget those negative signs. They're very, very important. So from top to bottom, this is how we solve one of these. In the next video, we will continue doing some examples.